Okay, here is my code for assignment 1. So starting off, we have the variables that I've added. So I made a variable for count, which will keep track of how many items are inside the deck, or the array rather. And front keeps track of front, and since it's double-ended queue, I also need to keep track of rear. And I made another variable for the array size, so I did not need to modify the initial value of max size equals 5. That's for expanding, which I will show later on. And here is, I guess, a generic array. That's what's going to be used for the deck. So just run it now and make sure it works correctly. Give it a minute or a few seconds here. Okay, there we go. Now, as you can see, here's the correct output. So it's all working correctly. Yeah, that's both the string and the integer version. So first start with the size method. It's extremely simple. It just returns the variable count, which keeps track of the amount of items inside the deck. Just returns the number. Next we have clear, which resets all three variables, so count, front, and rear, back to 0, which basically just clears the whole deck, and if there's any items stored in the array, they'll just become overwritten, they become irrelevant. So pretty simple there. Next we have is empty. Let's return true or false if it's empty or not. If size returns 0, yeah, size is here, returns a count. If it returns 0, it's true. If not, false. Very simple there. And next, add first adds to the beginning of the deck, the front. So first off, if the size is equal to the array size, meaning it's full, there's no more room left in the array, we need to expand. So I added this, I will show that later. That's the first step. But for actually adding to the front, first off, I put an if statement for if size is equal to 0, don't need to worry about anything, just add value x straight to the front. Don't need to worry about anything, and then just add 1 to count, so it keeps track of the amount of items inside the array. Pretty simple. Otherwise, if we're just adding to the front, besides those conditions, here I used this formula to add to the correct index of the array. So this is like modulus, but since I used front minus 1, front could be 0. And if it's 0, you're dealing with a negative number here. It'll be -1 modulus the size of the array, which in this case is 5 to start with. And that would return a negative number, which would not work in this program. So I had to use the built-in Java method from math class called floormod, which essentially will return the remainder in this case. So if it was -1 mod 5, it would return 4, so it would loop back to the end of the array, because it's for a circular array, right? If that makes sense. So yeah, for a circular array, you need this kind of formula for it to work. So I added that, and once you successfully change the value of front, then you can go ahead and add value x and add 1 to count. Same deal. Pretty simple. Okay, now add last. Same thing, except we're adding to the rear of the array. So yeah, parameter value x, same deal. If the array is full, we need to expand. I'll show that later. If there's nothing in the array, just go ahead and add x to value rear, no problem. add 1 to count, you're on your way. Otherwise, this is the formula to get the correct index for rear. So front plus count. In this case, I used the modulus operator because there's no problems here. There's no negative values since front is never negative. It's always non-negative, 0 or positive. So that's all good here. Same thing. Add rear value x to rear and add 1 to count. Next up, we have remove first. So has to remove the item from the front. Okay, if the array is empty, if count is equal to 0, then it has to throw an exception. No such element. In this case, I wrote there are no elements in the array, so you can't remove anything because there's nothing there. Just throws an exception if there's nothing there. If there is something in the array, then this will run, and I set a variable of element removed that is equal to the front of the deck, so I can return it later. And I simply change the value of front to the next one over. So this is the formula that goes for the circular array formula, I'll call it. Moves to the next one over, and whatever the previous value of front is, it's still stored in memory, but it becomes irrelevant and will become overwritten by the program later on. And count is subtracted by 1 to keep track of everything. And it simply returns the element that was removed, which we stored earlier. Okay, remove last is essentially the same thing, except, again, if it's 0, throws an exception if it's empty. Same thing, except we save element removed to the rear this time instead of the front, and the formula is concerning the rear. So since it's -1, I used floor mod again from the math class, so we wouldn't have a problem with negative numbers. And count -1. Same thing. Next up, we have our get method. So this one only works if front is index 0, right? And then so on. The next ones are 1, 2, 3, etc. So, okay, if index is less than 0 or greater than the size of the deck, it just returns an out of bounds exception, meaning you can't get anything from there because there's nothing there. It shouldn't return anything. So I made a variable called output, which is equal to the value store the specified index in the deck. And it just returns that. I honestly didn't need to put that there at all, but it's there. Okay, next, get last is even more simple. It just returns the rear. And if the deck is empty, it just returns an throws an exception rather. So yeah, just returns the value in deck rear, which is the back of the deck. Okay, get first, exact same thing, just returns the front, same thing. Nothing special there. Okay, toString method just prints it out on the screen for you to see what's inside the deck. So I have an iterator which gets set to whatever the value of front is because it might not be 0. It's a circular array, so things change. And it iterates the amount of times of elements you have inside the deck, that many times. And here, what was this again? If I is less than count -1, yes. So if I is less than, okay, I put if statements here because I was being picky. This is really not that important, but if count is less than the last index of the deck, it will output, or it'll add to the string, which is output. Where was I? Here. It'll add the value at index iterator in this case it'll add, or it'll, oops, shoot. There, okay. It'll push to string and it will add a comma and a space. No, I also already added a square bracket here just to make the output look good. The only reason this if statement exists is because I wanted to add this comma and a space, and if it's the last element in the deck, which is equal to, not less than, equal to count minus 1, it will output the exact same thing just without a comma and a space. That's all that is. It's a little bit confusing, but that's what the if statement is. And it just gives you a nice output, as you can see here. Just nice and clean. Square brackets, elements, and commas with no space or any extra stuff at the end. It just looks correct. Okay, and lastly, it just tacks on a square bracket at the end. Pretty basic stuff. And returns the string output, which is visible here, for example. Okay, lastly, we have our expand method here. Pretty simple. It just creates a new generic array called expanded array, and this is size 2 times the array size. So whatever the array was before, the size, it just multiplies it by 2. So if it was 5, it's now 10, the new one rather. So it iterates through the old deck, and this is called normalization. It just copies it over to the new array, except front is now set to 0. So it starts at 0, it adds front to 0, and just tacks everything into the new array. And then I set deck to the new array, just set it to that, and then I reset the front variable so it all runs correctly after. And array size is multiplied by 2. Yeah, I used array size instead of max size because I did not want to modify the initial value. And that's all. That is my program. Here's the output. Seems to be all good. Thanks.